Something invisible is holding you down right now. It decides how fast you fall. It controls the motion of the moon. It shapes stars, planets, and entire galaxies. Yet you cannot see it, you cannot touch it, and most people never truly understand it. Every second of your life, this force is at work. It pulls your body toward Earth. It keeps oceans from drifting into space. It locks planets into perfect paths around the sun. Without it, the universe would fall apart. So why do things fall down? That question sounds simple, but the real answer changed science forever. It challenged the smartest minds in history, and even today, it still hides deep secrets. This video is not just about objects falling, it is about the force that shapes reality itself, a force so familiar that we ignore it, and so powerful that nothing can escape it. Gravity is everywhere. But what is it really? For centuries, humans believed they understood gravity. Then they realized they didn't. Some thought it was a natural tendency. Others believed it was a hidden pull acting across space. Later, scientists discovered that gravity is not just a force at all. It is something far stranger. Gravity bends space. It slows time. It can trap light itself. There are places in the universe where gravity becomes so strong that time nearly stops, where falling never truly ends, where the laws of physics begin to break down. And here is the lesser-known truth. Gravity is the weakest force in nature, yet it controls everything on the largest scale. It cannot be turned off. It cannot be blocked. It reaches forever. In this video, you will learn what gravity really is. Not the textbook definition, not the oversimplified answer, but the deeper story behind it. You will learn why all objects fall at the same rate, why astronauts float even though gravity still exists, why planets never crash into the sun, and why gravity might not behave the same everywhere in the universe. You will also discover facts that most people never hear, like why gravity affects time, why light bends near massive objects, and why scientists still cannot fully explain how gravity works at the deepest level. This is not ancient history. This mystery is still unfolding. Right now, scientists are searching for answers that could change everything we know about the universe. By the end of this video, gravity will no longer feel ordinary. You will see it as a silent architect of reality, a force that connects you to the edge of the cosmos. And once you understand it, you will never look at a falling object the same way again. Stay with us till the end, because the final part of this video reveals why gravity may be the key to unlocking the deepest secrets of existence. Welcome to our channel. If you enjoy clear explanations, powerful ideas, and science that makes you think differently, you are in the right place. Subscribe now, and let's explore the forces that shape our universe together. Gravity is a force of attraction between things that have mass. Any object that has mass pulls on other objects around it. This pull is called gravity. You cannot see it, you cannot touch it, but you can see what it does. When an apple drops from a tree, gravity is at work. When your feet stay on the ground instead of floating away, gravity is the reason. It is always there, acting quietly, shaping every movement. Gravity does not need contact. Objects do not have to touch for gravity to work. The pull travels through empty space. It works between you and the earth. It works between the earth and the sun. It even works between distant stars. The strength of gravity depends on how much mass an object has. The more mass there is, the stronger the pull becomes. Everyday life is full of examples of gravity in action. When you jump, you move upward for a moment, then you come back down. Gravity pulls you toward the center of the earth. It never stops pulling, even while you are in the air. You only feel the effect when you land. When you throw a ball, it rises, slows down, and then falls. Gravity is guiding that motion the entire time. Earth has a huge amount of mass. Because of that, its gravity feels strong to us. It keeps the air wrapped around the planet. It holds oceans in place. It keeps buildings, trees, and people firmly on the surface. Smaller objects also have gravity. A book has gravity. A coin has gravity. Even your body has gravity. but their mass is so small that the pull is too weak to notice. The force is there, but it is overwhelmed by Earth's much stronger pull. Long before modern science, people tried to explain why things fall. One of the earliest ideas came from Aristotle. He believed that heavy objects fall faster than light ones. He thought objects were moving toward their natural place at the center of the Earth. According to this view, falling was a natural behavior, not a force acting from a distance. This idea shaped human thinking for nearly 2,000 years. That understanding began to change with Galileo. He questioned the old beliefs and tested them. Through careful observation and experiments, he showed that objects fall at the same rate, no matter how heavy or light they are, as long as air resistance is removed. This was a radical idea at the time. It showed that gravity acts equally on all objects. Weight did not control the speed of falling. This discovery challenged centuries of accepted thought. Later, Isaac Newton took this idea even further. He realized that the same force causing an apple to fall was also controlling the motion of the moon. Gravity was not just something that happened near the ground, it was a universal force. Newton proposed a clear rule. Every object in the universe pulls on every other object. The strength of that pull depends on two things: how much mass the objects have and how far apart they are. According to Newton's rule, larger masses create stronger gravity. Shorter distances also increase the force. This explained why Earth pulls strongly on objects near its surface. It also explained why planets follow predictable paths around the sun. Gravity was no longer just an idea. It became something that could be calculated, measured, and predicted. Newton's law of gravity explains the basic rules of how this force behaves. Any two objects attract each other. There are no exceptions. A planet pulls on a star. A book pulls on the Earth. Even two people standing next to each other are pulling on one another. The effect is usually too small to notice, but it is always happening. Gravity does not choose sides. It works between all masses everywhere. The strength of this attraction depends on size. The bigger the masses, the stronger the pull. Earth pulls strongly on you because it has an enormous amount of mass. You pull back on Earth as well, but your mass is tiny in comparison. Distance also matters. When objects move farther apart, the pull between them weakens. This is why gravity feels strongest near Earth's surface and much weaker far out in space. These simple ideas allowed scientists to predict motion with great accuracy. Newton's explanation worked extremely well. It could describe falling objects, moving planets, and even the paths of comets. For a long time it seemed complete, but there were small details that did not quite fit. Tiny shifts in planetary orbits hinted that something deeper was happening. This is where a new idea changed everything. Albert Einstein approached gravity in a completely different way. Instead of seeing it as a force pulling objects together, he described it as a change in the structure of space and time. According to Einstein, mass bends space, time bends with it. Objects move along these bends, following the natural shape of the universe. What we feel as gravity is really motion through curved space-time. This idea was revolutionary. It explained things Newton's laws could not. It showed why time runs slower near massive objects. It explained why light curves as it passes near stars. Gravity was no longer just a pull. It became the geometry of the universe itself. On the largest scales, gravity shapes everything we see. It keeps planets locked in steady paths around their stars. Without gravity, planets would move in straight lines and drift away into the darkness. Stars themselves are born because gravity pulls clouds of gas together. As the pull grows stronger, heat and pressure rise, and a star ignites. Gravity also binds galaxies together. Vast collections of stars move as one because gravity holds them in place. Even galaxy clusters, some of the largest structures in the universe, exist because gravity connects them across enormous distances. This force reaches across millions of light years, quietly organizing the cosmos. In extreme cases, gravity becomes overwhelming. Black holes form when massive stars collapse under their own gravity. The pull becomes so strong that not even light can escape. Space and time are distorted beyond normal limits. These regions reveal how powerful gravity can become when mass is concentrated into a small area. Closer to home, gravity defines life on Earth. It gives objects weight. Weight is not the same as mass. Mass is how much matter something contains. Weight is how strongly gravity pulls on that mass. On Earth, gravity causes objects to fall at about 9.8 meters per second squared. This value shapes how we walk, run, build, and live. Gravity keeps the atmosphere in place. It holds oceans against the surface. It controls the movement of tides through the pull of the moon. Without gravity, Earth would not be a stable home. Everything not attached would drift away into space. There are also surprising facts about gravity that make it even more mysterious. Among the fundamental forces of nature, gravity is the weakest. Other forces easily overpower it at small scales. Yet gravity has an unlimited range. It never fades completely, no matter how far it travels. This is why it dominates the universe on large scales. Gravity can also affect light. When light passes near a massive object, its path bends. This bending allows scientists to see distant galaxies that would otherwise be hidden. It also proves that gravity influences not just matter, but space itself. Despite everything we know, gravity still holds secrets. Scientists can describe how it works with great precision, but the deepest reason for its existence remains unknown. It does not yet fit neatly with the other forces of nature. Research continues, pushing closer to an answer that could reshape our understanding of reality itself. Gravity is an invisible pull between objects with mass. It is always present, even when we do not notice it. It guides falling objects, holds us to the ground, and keeps the Earth in motion through space. What feels ordinary in daily life is actually one of the most powerful influences in the universe. Newton gave the first clear rule for gravity. His work showed that every object attracts every other object. With this idea, motion became predictable. Planets followed paths that could be calculated. The universe began to make sense in a new way. Einstein then transformed that understanding. Gravity was no longer just a force pulling things together. It became the bending of space and time itself. Massive objects change the shape of the universe around them, and everything else moves along those curves. This revealed a deeper layer of reality hidden beneath what we see. From apples falling from trees to galaxies spinning across billions of stars, gravity shapes everything. It connects the smallest moments of daily life to the largest structures in existence. It is simple to feel, yet endlessly complex to explain. Now think about this. What would happen if Earth suddenly had no gravity? Share your thoughts in the comments below. If this video helped you see gravity in a new way, support the channel by liking the video and subscribe to our channel for more clear, powerful explanations that explore the forces shaping our universe.